Hello guys, welcome to AR Tutorials. Today is day 27 of solving Leet Code questions daily. Friends, from yesterday we have started our binary search playlist, and today I'll be covering the two main important and fundamental topics with regards to the binary search, that is the upper bounds and lower bounds. So this video will be specifically dedicated to the lower bound values. And once you know the lower bound, upper bound is just a piece of cake for you. Just one sign change and you will get the upper bound. And I'll surely share you a technique where we can convert or we can get lower bound from the upper bound function only. Means you only have to write one function of lower bound, automatically you will get the upper bounds also, but that will be shared in the next video. Which will be I'll be posting immediately after this. So first we'll see what is the lower bound and where we have to use the lower bounds. So lower bounds are nothing but they are the first occurrences of any number, which means if you have given the number, it first calculates the first occurrence that it is present in this. If it's not present, it tells you that this place is the most identical place where this element could be found. Which means that if my number is 4 and my set contains only 1 and 5, so it returns me the index 0, where my why 0, because my arrays consist of only two elements, that is 1 and 5. So it tells me give the index 0, that is the lower bound, that after this and immediately after this your element is very appropriately stable to be fit inside this space. So it tells that. And what is the upper bound? Upper bound just tells the last occurrence, that is after this this element is greater than that. Means if I have a number 1 3 5 and my number is 2, so what it no my number is 4, so what it tells first, what will be the lower bound? The lower bound would tell the first that this is the appropriate place, and upper bound will tell it will only take this number is greater than the target, so it should be placed here. So I think I should explain more. So whenever you see less than equal to, it is a upper bound, and when you see a greater than when you see greater than equal to, it is a lower bound. So when you see it is a lower bound, and when you see only greater than, it is a upper bound. So what it does, it occurs the first occurrence, it occurs the last occurrence. So it's all the game of occurrences. Once we'll go deep inside this binary searches, we will get to know what are the search spaces and how the occurrences matter, how the numbers matter, how the changes of the neighbors element matters. Because once you come to know how the lower bounds and upper bounds actually work, so this will be very efficient for you to properly analyze that what we have to do. So here we have given the question as floor of the sorted array, which is basically you have to find the minimum value. What is the floor? Basically floor gives if my number is 2.5, it returns me 2, which means it has a lesser value, and that is the lower bound now. So here what we have to give, we have given the number 7, that is the size of our array. We have given x our target at 0, and this is our array. What is my output? It is -1. Because why? What is lower bound tells? It tells greater than equal to. And what upper bound tells? It tells greater than. But the 0th number is less than these numbers now. Whatever the values are, the 0 is less than, so it returns -1. As easy as that. But when you check this this array, we have to insert 5. So where we have to place the 5, it tells us the output 1. Let me clearly show you. Okay. So why it tells the largest number is less than 5 is 2. So this number is less than 5, because what we have to basically tell, the target should be greater than or equal to. So equal to values are not there. 5 is obviously greater. So immediately lesser than value is what? 5. So 2. So 2 is present at the index 1. So we'll return 1. Easy. So we'll just see the code. Nothing, I'll just find a floor long because it has given me some data type. It is predefined data type. So we'll just use it for the computation. Long log is the bestest data type because it will never exceed the integer type, and you will get flawlessly insane outputs when you use long data type. So these are the data types. So first, low and high. I told you in the yesterday's lecture what binary search involves. It involves low and high. The first is at the 0th index and the high is at the n-1 index, and answer is just a variable which we are going to store our value. So we'll loop it until the low is less than high. Then we'll find out the mid. After finding out the mid, we'll check the element inside that array. This is the element inside that array is greater than the x. So I have told you what is greater than. It is upper bound. So we are going to check the upper bound here. So if my number is greater, I have found the upper bound. So I have to just reduce my search space from left side. Let me just visualize you for one. Okay. So this is my array. So here is my mid and here is my high. From I know that from high to mid there is no use space, so I'll just terminate all this stuff and I'll just shift my high to the mid -1 index, that is this high, and this is low, and I'll just do it whatever I have to do in this search space only. So this logic. And in the else part, what I have did for just low plus mid minus low, I have shifted. If it's lesser space, we have to shift low. If it is greater than, we have to just shift high. And whatever answer will be there, it is stored here in the low. If you return low also, you will get obviously correct answer. But for a safer reason, you should always return a variable which consists the mid values. So I'll just run this code. It runs finely. So okay, so this is our the answer, and I'll just tell you the okay. So everything, I think, how okay, it is running fine, well and fine. So thank you guys for watching this video. I'll quickly post another part of this video, so please stay tuned.